Hey guys, how you doing? This e-learning module is going to be on the Wankel engine, and we'll get started on this one. Now, the Wankel engine is otherwise known as a rotary engine. If you're into Mazdas, that's what a lot of them have used over the years. We're going to first talk about the operation of the rotor, which would be the center part of this right here. And let's read through this real quick. It says the Wankel engine is a variant on the combustion engine that is not often seen. You will see its counterpart, the piston engine, the most, and that's what we took apart in our autos class. The Wankel engine consists of a triangular rotor, which is the centerpiece here, that rotates eccentrically, which means in an oval shape, within a housing. Eccentrically means not in the center. The rotor continues to a pressure increase on the rotor side. When a combustible mixture is ignited, a pressure increase is created. And you'll see we got the spark plug right here. We're going to have air and fuel coming in right here, and then we'll eventually have combustion happening in the bottom and then exhaust going out over here. The rotor rotates over the crankshaft. When the rotor makes one revolution, the crankshaft makes 3 revolutions. So 1 revolution of triangular piece equals 3 revolutions of my crankshaft. The crankshaft rotates in a stationary gear that is installed on the rotor housing. A flywheel is installed on the crankshaft. This stores energy during the power stroke. The flywheel releases this energy to the crankshaft during the other strokes. And all of that is exactly the same as when we talked about our 4-stroke engines that we took apart in autos class. Our first question is, which internal combustion engine do we see the most? And unlike the module, what we typically see is a piston engine. This is what most cars are going to have. And go to the next one. And now it wants us to find 3 parts. We've got the crankshaft in the center here. We have our stationary gear, which is not going to move right there. And then we have our triangular shaped rotor on the outside. Now it wants us to click the button to make the rotor move. As we hit play, you're going to see the center part doesn't move, but my triangular shaped piece moves in that eccentric shape, and that's what's going to allow us to get the 4 phases of our 4-stroke engine. So the rotor does move up and down. The rotor will start to rotate, and the rotor moves up. Go to the next one. Now it wants us to click the button to make the rotor move and to draw the rotor housing. So check this out. We're going to see this shape again in the next slide, and this is the path that it changes here. Now it asks, click the button to make the engine move. And it wants to know how many revolutions does the crankshaft make after 1 revolution of the rotor. And as it says right here, 1 revolution causes the crankshaft to make 3 revolutions. So we're going to type 3 and go to the next one. Now we're going to look at some pressures here. It says increase the pressure on the rotor side by pressing the button. So if you watch the needle here, you're going to see it bump up a little bit, and then it's going to come back down. And the crankshaft starts to rotate, and that's what we saw with this piece spinning. The space ultimately increases right here, and the rotor ultimately gets pushed away. Hit check. We did good. So we'll go to the next one. Now there's a combustible mixture of fuel and air in the rotor housing. So over on this side, there's considered air and fuel in there, and it got it from this space right here. We're going to hit play and see what happens. You're going to see a big flame, and you're going to see this temperature spike up, or you're going to see the pressure spike up. And that's where my explosion happened, my combustion right there. So, did our temperature increase? Yes, it did. Did the rotor deform? No, we want this piece to stay the same shape the whole time. So we're going to hit false down there. The rotor turns on its own axis. No, it does not. The pressure increases. Yes, it does. And the rotor will start to rotate. Yes, it does. We'll move on to the next one. And if you want to see that again, just press the reset button right here and you can watch that happen again. So now we've got a flywheel on here, and as I say in class, it's a little extreme when I say this, but engines are lazy. They're only creating power 25% of the time. So we've got a flywheel right here that's got a lot of mass that's going to help our engine kind of carry through that 75% of dead time. So click on the flywheel, and now you can kind of see the silhouette of the flywheel going around there. And what they want us to do is click on the flywheel when it starts to release its stored energy to the crankshaft. So right after you see the flame is when you want to click this. Right there. And you might have to try a couple times. It's a little tricky. Right after you see the flame, you want to click it. And we're going to move on to the second bullet point. So now we're going through the Wankel process. And let's read this. It says the Wankel process continually repeats. This process consists of one cycle and 4 strokes. One stroke lasts 3/4 of a crankshaft revolution. And we've got the intake stroke, we have the compression stroke, we have the power stroke, and we have the exhaust stroke. And this is all the same as when we talked about our regular lawnmower engines. So it's asking us which strokes make up the Wankel process, and you can look right here to double check, but it is the compression, it is the exhaust, intake, and power. Check those, and we did good. Now what you're starting to see here is we got intake, compression, power, and exhaust. Intake, compression, power, and exhaust happening over and over. So we're going to go through the first stroke using the slider bar. So down here, grab the little slider, and what you're starting to see with all that green coming in is our intake phase. We're bringing in the air and the fuel. We did good, so we'll go to the next one. Now we're going to slide between the 1 and the 2. And it's asking us what happens during the intake stroke. And during intake, the air-fuel mixture flows into the rotor housing via the intake port. So our first one is going to be true, and the rest of them are going to be false. Now we'll move on again. It says go through the second stroke using the slider bar. So we'll slide through the 2 phase right here. And now what you're seeing is all that air and fuel getting compressed, getting squished into the tiny little space here. This is going to be the compression stroke. And now it's going to ask us what happens during the compression stroke. And it says right here, the fuel-air mixture is compressed. So let's find that one. Right here, the fuel-air mixture is compressed. That's true, which makes the rest of these false. And we'll move on to number 6. We're going to go through the third stroke here. Slide the bar through the third stroke. And now we're seeing that spark plug ignited it. And now we've got a flame traveling through here, creating all of our power. So this is going to be our power stroke. We'll go to number 7. What happens during the power stroke? The power stroke, the compressed mixture is ignited and the rotor is pushed aside. So the air-fuel mixture is ignited, energy is delivered, it was compressed before, and it's not flowing through the intake housing, intake port I should say, and we don't have anything going out the exhaust yet. There we go. We'll go to number 8, and now we're on to the 4th stroke. Use that slider bar, take it through the last part here, and now you're going to see all of our burnt air and fuel, all of our exhaust is going to go out the exhaust part, and so we call this the exhaust stroke. Go to number 9. So during the exhaust stroke, the combusted gases are forced out of the rotor housing. So we find that one right here. The combusted gases flow out of the rotor housing. which makes the rest of these false. Going on to number 10. And now we can see all this in action. See the rotor going around. And what do we notice? Per revolution of the rotor, there are 3 power strokes. That's going to be true. 1 stroke is covered simultaneously on each side of the rotor. That is also true. Per revolution of the rotor, there are 2 intake strokes. That's going to be false. And per revolution of the rotor, there is 1 exhaust. That's also going to be false. Now it asks, how many revolutions did the crankshaft make after 1 revolution of the rotor? And we talked about that before, it was 3. On to number 12. How many work strokes does a Wankel engine have per crankshaft revolution? And it's going to have 1 work stroke per crankshaft revolution. There we go. So we finished this module, and I hope this helped you guys out. If you had any questions, feel free to talk with your teachers.